Pajarito, presente. Osvaldo.
¡Pajarito! ¡Ten cuidado, pajarito! Aquí.
No, izquierda. Fernando. Aquí. Gisela. Sebastián. Aquí. Ian. Aquí. Daniel. Aquí. Oscar. Carlos. José Miguel. María José. Chelsea. Sofía. Sebastián. Bruno. Rodrigo. Joel. Paulo. Andrea. Marcela. Joana. Angélica. Paola. Sofía. Mía.
Ya están radiales.
Mariana. María Isabel. Rafael. Daniel.
Presente.
Guillo. Okay. Fine. If you remember, I told you Monday that this weekend you have an activity to do Blackboard, right? So, what is the activity? The activity is going to be learning units. Where the activities start at the end of the page, the very bottom of the page, where it says diagnostic activities. It's this one. Okay. For this activity, it will be available from today at 5 all the way until Sunday at 11:59. The activity has 10 exercises. About what? About simplification mostly. Simplification using a special product from Math 2 and also identities. Trigonometric identities from Math 4. Exercises. You have 60 minutes to do them. And you have 5 attempts to do them. And I'm going to take the highest grade that you get. So for example, if in the first one you fail, you went to the second time and you get 100, then the 100. My recommendation is that even if you pass or you obtain 100 or 90, something like that, try to follow with the other attempts so you can practice, because there will be different exercises every try that you do. Okay, so until Sunday, please don't forget that, because if you forget that, then you are going to lose 5% of the partial.
The exercises are about
No. Basically, simplification. Simplification of algebraic expression. Okay. Questions about this? No? In case that, for example, in one of your attempts, the Blackboard closes, I don't know, because of your internet connection or something, try to send me a print screen of the message that I have, so I can give you another attempt in case it happens. Okay. Okay. Check out the activity, please. The activity 2.2, the one that we did yesterday, so we can check the answers of the first part. Okay, so we already did some of them here in class yesterday, but it doesn't matter. We're going to check all of them to see if you have any questions. The first one, it says square root of x as x approaches 0 from the right. So First answer 0.3, then 0.1, then 0.03, 0.01, 0.000003. So the limit approaches what? 0. Okay, because the value of the function keeps getting lower, 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 smaller, smaller, smaller. Second one, f of x equal to 1 over x as x approaches infinity. When it's 10 is 0.1, when it's 100 is 0.01, etc. So the final limit approaches 0 also. The third one, 1 over x as x approaches 0 from the right. 0.1 is 10, 0.01 is 100, 0.001 is 1000, etc. So at the end the limit approaches infinity. Try to observe that, for example, here, this is also important, that when you divide a number, let's say 1, 2, 3, or whatever constant you have, and you divide it by a very, very small number, actually increases. So try to keep that in mind, okay, because of the next part. We're going to see this one again in the next part of the topic. Okay, number 4, 1 over x as x approaches 0 from the left, minus 10, minus 100, minus 1000, so approaches negative infinity. Number 5, ln of x approaches 0 from the right, negative 2.3, negative 6.9, negative 9.2, negative 35.32. So approaches negative infinity. 6, ln of x approaches infinity. 10 is 2.3, 6.9, 9.2, 23.03. So the answer goes to infinity. Number 7, approaches 4. There's a little correction here. Here, when you evaluate at 2, the answer is doesn't exist. Okay, not 4, doesn't exist. Okay, but the limit approaches 4. Number 8, we did it yesterday. It approaches E, the Euler number. Number 9 and number 10. Careful, because the instruction said to use radians. Remember radians from last semester?
No.
No.
Can you explain, please?
Yeah.
Se rapa.
Basically, last semester in Math 4, you saw that there are 2 units that we use to measure angles. One of them are the degrees, the other one are the radians. Okay? If, for example, if you use degrees here, the answer is going to be wrong, because in this case, for example, if you're using sine, cosine, tan, etc., and this value, if you put it in degrees, the answer is going to be different. So in this case, the answer is by using radians. How do you change the calculator to radians? There's a way. In the calculator, you put the button that says mode, and you have the option to change it to radians. If you do it, and you put the values, and this. Here in calculus, we're going to use mostly radians. So if you leave the calculator in radians, then that's fine. Nothing is going to change. The only thing that changes is when you use trigonometric functions. But we're going to use radians for that. The answer then is 1. Approach is 1. Some of you told me yesterday that the answer here was 1 also, but that's because the calculator rounds the number. But still, it approaches 1.
So if you put 1 in the side, it's going to be 1.
No, because that will be the question. Find the limit of this, and the answer will be 1. The next one, number 10, same function, but approaches 0 from the left. Again, the answer is going to be 1. So, the last question says, do we have a limit at x equal to 0? The answer is yes, and the answer is 1. Why? Justification, because from the right is equal to 1, from the left is equal to 1, so the full limit approaches 1. That's the justification for this. Good. Questions?
No. ¿Tenemos que hacer esto?
No, we'll start today in class. We're going to finish for 1 week. So the next part of the topic is, right now we have seen how to find a limit using a table of values, just like this, or using the graphs. There's another way to do it. The third way to solve a limit is by using a direct substitution. Okay, ready? It's basically the continuation of the previous one. Okay, so the third way to solve a limit, and the most practical, is by the direct substitution. What do I mean by that? For example, we have this one. We have the limit x approaches 3 of x plus 4. If I were to solve this graphically, what would you do? You will need to graph this function. This function, x plus 4, what kind of graph will be that?
Linear.
It's a linear function, so it's a line. What kind of line? How can I graph that? How?
It starts in 4.
Yeah, it starts at 4. 1, 2, 3, 4. And from there? Yeah, because the slope is 1. No. Okay, in this case, for example, it says approaching 3. So this is the 1, here is 2, here is 3. So I need to know what happens. How can I find the value of the limit by using the graph? No, okay. But by doing the graph. Here's the 3 here. The x-coordinate 3 is here. What's the corresponding y-coordinate?
5. 7.
7. 1, 2, 3, 4, 5, 6, 7 more or less. Let's say here.
So you substitute 3 in the x.
That would be the idea. Wait. Okay, here is the 7. If I do the limit graphically, it means that I need to see what happens. As I approach the 3, my graph is approaching what? 7. 7 will be the answer for here. That's by using the graph. If I were to use the table of values like we did yesterday, what will I need to do? To substitute, I will need to give values to x and see what happens with the f of x. Then you will say, okay, what will be the values for x that I need as I approach 3?
2.9.
Let's use 2.9 and 2.99 and 3.01 and 3.1. Okay? So if I evaluate, then I have 6.9, 6.99, 7.01 and 7.1. So at the end, my function is approaching what value? 7. So the idea of direct substitution is that to avoid all of that information, to avoid all that procedure,
Well, what do? I can just plug the value in the x and then just solve it.
Okay? So,
But why is that? Because of this, observe. Based on the graph, the answer is 7. By finding the values, it approaches 7. Well, in this situation, instead of all of that, I can just substitute 3 instead of x. 3 plus 4 equal to 7. That's the answer to the
No manches, bro.
okay?
Teacher, but that works every time or just in this case?
No. See, it doesn't work.
Here, you can,
That's a problem. Okay, so yeah, that's the third approach, by substituting directly the value that I have in my function and solving. That's the resolution. Yeah.
And what if it tells you from the left side? Is the same?
Go into that. Okay. What is that?
Or the right side?
When does that work? If you see the function and the value that you're checking, if that value is in the domain of this function, without any kind of trouble or problem like that, you can just substitute.
What? Sorry, can you repeat that? Sorry.
Yes.
How do we get the domain?
That's. We'll already know that, no? From 3, 2, 1.
Zero.
To solve a limit by direct substitution,